Okay, guys. Welcome back to topic 6, calculus review. This is subtopic 6.2. 6.2 is a subtopic with a lot of theory, so I'm gonna try to get through as much as I can in this video. But I doubt I'll finish all of it. So basically, in the last video, I talked a bit about first principles. Now this subtopic is a lot more about applying calculus, but kind of this is a shortcut of the first principles. So you're not really using the first principles, but everything is the first principles. These are just kind of shortcuts that we use because for really complex functions, first principles takes too long to actually use the original or the format. So here are a couple of functions that are ones that you need to know just by memory, basically. But they're also intuitive. So if you have basically a function that is equal to a constant, so f of x is equal to 2, then the derivative of x is always going to be equal to 0 of just a constant number. And you think about this when you graph a constant, so like f of x is equal to 3, the slope is 0, so it makes sense that the derivative is 0. Now here we have another function, and we have a constant times x. In this case, as the constant is not by itself, it's not going to get changed. When it's being multiplied by a variable x, it will just stay there. Now, when we do the derivative of a function of x, we always take its exponent down 1. And we bring what it is to the power of down to multiply by. So it's to the power of n, so the n is going to come down. The k is going to stay because the constant stays when it's being multiplied by a variable, and the exponent is going to go 1 down, so it's going to be n x to the power of n minus 1. Yeah, that's the derivative of k times x to the power n. Now these are some 3 trigonometric relations. And basically, these all have their own derivatives that are basically just memorized. So the derivative of sine of x is always going to be cosine of x. The derivative of cosine of x is always going to be negative sine of x. And the derivative of the tangent of x is the secant squared of x, which is 1 over the cosine squared of x. So yeah, these you basically just need to memorize. Of course there's proofs for them, but I'm not going to do them. You don't really need to know the proof. You just need to kind of memorize these. And then a really important one, an interesting one, is that the derivative of e to the power of x is always just e to the power of x. So the derivative of the function is itself, which is an interesting property. Alright. Now another couple of things we need to know is, first of all, the addition rule. So let's say we have a function x which is equal to e of x plus sine of x. If we want to take the derivative of this function, so of the addition of two basically two terms, right? This is a term and this is a term. We just kind of take the derivative of each term by itself and just add them to each other. So the derivative of e of x, remember, is just e of x, and the derivative of sine of x is going to be cosine of x. So that's going to be the derivative of that function. Alright, so that's just an easy thing that you need to know. Okay, so a very important rule that we use a lot in calculus is known as the chain rule. And basically we use this rule when we have functions that are basically a little bit more difficult to differentiate. And basically that translates into functions that are basically consists out of a function inside of a function. So let's say, for example, we had this function y is equal to let's say g of u, where u is another function f of x. Then if we wanted to find the first derivative of this function, we'd say dy dx is basically the derivative of the first function, so the dy du times the derivative of the function inside of the function. So that's this one. So times du, which is the second function with respect to its variable, dx. And that kind of makes sense because these kind of cancel out to give you dy dx, which is what you're looking for. So basically you find two derivatives here. So let's do an easy example so that it makes more sense. Let's say f of x is equal to the sine of e of x. So here we basically have two functions, right? We have the sine function and the e function. So if we want to find the derivative, we'd first do the derivative of the first function, so derivative of basically just the function. So that will be cosine of whatever is inside the brackets. And then we'd still have to multiply that by the derivative of the function inside of the function. So derivative of e to the power of x. Remember, that's always just e to the power of x. And yeah, that's how you use the chain rule. Alright, so there's two other rules that should be known. And basically they're both pretty specific to their application. The first one is known as the product rule. The product rule is used when two functions are multiplied by each other. So if you have an f of x is equal to, let's say, u times v, where each of them is a function, right? They're both functions. If you want to find the derivative of this, we basically use the product rule, and the product rule just says if you want to find the derivative, just do each of them times the derivative of the other. So just do each of them times the derivative of the other one. So we have times v of x. So u of x, so that's 1 times the derivative of the other one, so v of x, plus the derivative of u of x times v of x normally. So you just kind of alternate between the derivative and the non-derivative, and you multiply and then you add them to each other. And that's the product rule. Product rule is really simple. Again, this can be proven with first principles. Then you have the quotient rule, which is a little bit more, maybe a little bit more complex, I guess. You have, and the quotient rule relates to dividing functions by each other. So basically, let's say you have this and this. So you have like two functions divided by each other. If you want to find the derivative of this one, what you do is you'd say, all right, the derivative of this function is equal to the derivative of the bottom one. First you begin always with the derivative of the top times the bottom one minus the normal top one times the derivative of the bottom one. So this is kind of similar to this one, except that you have a minus here, and then you divide all that by the original denominator, and you square that one. Yeah, that's the equation for finding the derivative of a function that is composed of basically two functions dividing by each other. So you just plug them in for each of these, and then you solve it or you simplify it, and then you found the derivative of a could be very difficult function, right? Yeah.